for this. Hey there, welcome everybody once again to Astronomy Daily Live. It is 2 hours UTC, um, and it is the 19th of June, 2019. I think it's the 19th of June, so that means we've only got a couple more days until solstice. So make your preparations. You know, most people don't do anything at all. In fact, most people don't even know that it's happening. So that's okay. That's completely their loss and our gain because it's just nice to know those kinds of things happen, and we have absolutely nothing to do with it at all except for noting it, observing it, saying, oh, it's the solstice. So, yep, that's happening in a couple more days, and I definitely like that day. I think that's probably one of my favorite days of the year. So, um, I don't necessarily do anything special or different or anything. I probably won't. But probably at the appointed time, I will go outside and sort of glance at the sun and wave. Look at your shadow at noon local time and see how short it is. Here, my latitude is about 32 degrees north. The equator is tilted, I think, at 23 and a half. Is that right? So I pulled out the calculator here. I'm going to do 32 minus 23.5. So the highest that the sun gets at my latitude is 8.5 degrees south of the zenith of that point, directly above us. So that's pretty high in the sky. 8.5 degrees. That's really, really, really close to almost straight up. So so yeah, and of course, as you change latitude, um, that changes too. If you happen to live on or near the Tropic of is it Capricorn up here or Cancer? One of the two, I forget which. The sun will be directly overhead. Yeah, and then if you're south of that line, the sun will actually be north of zenith. So very, very cool. Well, hey, before I start rambling on and going on and on about all things astronomical, let's say howdy to Bobby. Hey, what's going on?
Hey, Cosmic. Hey, Uncle B, Jim, Chuck, Tom. And we did have somebody else, but I don't know where she's at.
She's making a ruckus in the background. So yeah, howdy to Carolina Sky Astronomy, Uncle Bill, nerds rule, nerds rule.
There's
That
Rue.
that's it's just a fact. There's nothing really tongue in cheek about that at
Finally,
all.
there.
There we
And
go.
finally, there is the lovely and sexy, talented, tricky Miss Arthur Linda.
I know why I come on this chat. You bet.
What's happening, Anta? What's going on over there? Is it raining?
Well, I'll tell you, you're speaking to the president of the second largest club in my community. The computer club has 350 permanent members.
Okay.
My Star Trek club, which started a very short time ago,
Which club?
Star Trek club,
Star Trek. Okay.
now has 250 members who
Wow.
qualify to use one of our conference halls that has lots of audiovisual equipment in it. We can show movies, and now the group is so large we have to use breakout groups to discuss things.
Wow.
Stage Master helped me out a lot with a course he took. He gave me a bunch of materials. Now, I'm not having as much luck. Carolina predicted this. Getting an astronomy club off the ground, because people have this notion they have to own a telescope to belong to an astronomy club.
Right.
And while that's desirable, especially these days, it's not necessary.
Not at all.
Not at all. Now, and with the weather we've got in this part of the country, my God, I can't tell you how many times I use either Starry Night 8 or Stellarium or programs to see what my night sky would look like if I could see it. There's a lot of things you can use. Again, no, there is no substitute for seeing itself, is seeing it on your own with your own instrument. I get that. But I know there's a big interest in astronomy here because of how well attended the astronomy classes are.
Huh.
And their classes you got to pay for. They aren't free. So they're very well attended classes. I've gone to a few.
Wow.
And laughing. Carolina's laughing.
Yeah.
No wonder he is.
Yeah.
He was right, that devil. Well, I'm not giving up. There just needs to be a little education, because we have to have something around here. And I could see by the way the interest in the Star Trek Club grew, we've got to have something around here for elderly people to do besides drawing, quilting, and playing bridge. I mean, give me a break. I don't want to spend my golden years drawing pictures.
And we're being hailed
I'm sorry.
by Paychapter.
And the people just, it was really cool the way it started. I put on a Star Trek shirt, and I got a little table in front of where people go in to eat. We have many restaurants here. And I started getting the looks, these looks you get. You know the looks. You've all got them. Every nerd's gotten these looks.
What the hell?
I thought, I don't care. And then a few people showed an interest, and then a few more. Well, our first couple of meetings, we only had a couple dozen people, but then it just started growing like topsy. I mean, people were really interested in discussing these things. This isn't about entertainment. This is about what the stories meant. You know?
Okay.
And boy, if I can generate that kind of interest in an astronomy club, and I think I can. I think I just have to get over this hump that you have to own a telescope to be interested in astronomy. Not true. Well, enough about me.
Yeah,
Let's get on with the data.
It is really it is definitely best if you can have some kind of visual aid. Not just your eyes. You don't have to have a telescope, though. You can have a pair of binoculars. You can have a spotting scope, of some sort. It doesn't have to be anything much at all.
I know that now. I didn't know that when I began. But a lot of these people have like 10 by 50 binoculars because they've spent a lot of time traveling.
Right, with birds.
Some of them have some pretty hairy binoculars, to tell you the truth. I mean, ones that I would have trouble holding up. They'd have to get a camera tripod, for something. And there are tripods you can buy especially for this. So it's not like it's a big investment.
Probably, the place to sort of advertise any kind of, thought about forming a club is at those astronomy classes. See if you can get the teacher there, to either mention it or you go up and give a couple minutes presentation. I mean, you can.
Yeah, they're over right now. We won't have more classes until next spring. The astronomy class. The guy comes in once a year, and and does a few classes. But you're right. That is an excellent place to do it. In fact, if these people really wanted to do observing with a scope they could carry around and set up easily on your son's website, on his website, he does.
No, nobody's supposed to know about that.
Oh, hey, Mrs. Cosmic. Everybody's disappeared here, but on his website, he illustrates a celestron. He actually shows and sets up a celestron traveling scope. You can carry it around. Even an elderly, partially disabled person could carry it around. You can set it up easily. It's real light. It's 80 millimeters, I think. 80.
That's a good size.
80 millimeters. Yeah, about that much diameter.
Yeah.
And it's a nice scope. It's no harder to set up than a big pair of binoculars on a tripod.
Yep.
And it's only $109.
Wow.
Come on. Anybody living in this community where I live can afford $109. I can assure you.
That's funny.
We have indoor swimming pools here, for God's sake. This is not where poor people live by any remote stretch.
Right. Well, yeah.
Before the rambling, we like to welcome Paige. This is the assessor, Captain Burgess speaking. The world is round and goes around regardless, but the nerds can teach you about it.
That's right. That's exactly true. The other opportunity, of course, is to have another star party.
Yeah.
And just say, hey, have a sign-up sheet, right? And you'll try to contact them, have some way of contacting them, email or of whatever.
That's an idea. That's something I could do this summer.
Yeah, exactly.
In like a free time.
Because really, if you're pulling in a couple of hundred people at a star party, you'll pull all of them in at least the first meeting. At least the first meeting, you'll have at least that many, because they're just curious and or bored, right?
Yeah, right. Have me on the board out here. Not so much curious, but this is, it could be doable. In Cosmic's house. Look at Carolina.
What's
that?
Hey,
website to tell us the problem with the world today.
Yeah.
Check that out, Carolina. I'd like to know that.
Okay. Yeah. I don't know if there's a singular problem with the world or not, but
maybe I don't want to know it. Yeah, it could be. I don't want to know.
No, I can make up all my own. Thank you.
Yeah.
Very much,
Yeah, I'm pretty good at that too.
Yep. So am I. So yeah. So speaking of star party at my house, it's once again clear here. As you can see, the sun is still up, still setting. It is clear.
I see.
It is clear. It is dry. It is going to be dark for a little while. The moon is now past full, so it's going to be rising later and later each night, which means I'm going to have a longer and longer amount of time in real darkness. Dry, warm. It's actually warm. It was when I looked last night when I quit, which was early. It was about 11:15 or so. I'm not exactly sure. It was like 26 degrees Celsius. And Patrick is wondering, what do clear skies look like? Oh man, I'll show you a little bit if you want. I posted a few things over on the Discord server. So why don't we go over there and take a look? I think I've got that all set up. Yeah, I do. Wow. So let's share that. Do that, do that, do that. So I looked at two objects last night. The first was the Jupiter system, and this is just one image. It's just a raw image that I think I've stretched this a little bit. So this isn't exactly what it looked like on the screen, but you can see very overexposed Jupiter there. And then there's Io. Here, let me see if I can zoom in a little bit more here. So here's Io, here's Europa, here's Ganymede, and here's Callisto. And, you know, bad pixels in here. This is kind of an interesting little streak here. You see how that's going up that way?
Yeah.
That's also the, I think that's the path of the readout. So it's just, I mean, it's extremely overexposed. So, you know, these poor pixels here are just, you know, I mean, it's like Niagara Falls, right? It's just things are spilling out all over the place. And so with this short of an exposure, this is a 1/10 of a second exposure. And you know, just completely blasted Jupiter here. It's completely saturated. But what I'm mostly interested in anyway is the position and brightnesses of these moons as they move around. So I still have to think
And
about.
welcome Astro Live Channel. Yeah, imagine like the Universal fire. There's gonna be lawsuits. Think about how many lawsuits that YouTube is gonna have with all those demands.
Oh, look, you know, UMG was the biggest blocker, or is the biggest blocker on YouTube ever. And the fact of the matter is, for the past 11 years, they have not owned that music, because the only way that you can prove ownership is to
Have the
uh,
masters.
have the masters. If there's no
That's
masters,
it.
there's no ownership. So these guys have been banning YouTubers for years and years and years because they are playing UMG owned music, but they never owned it.
Hey, that's it. Talking about there will be lawsuits, and yes,
Oh, it's going to be great.
Yeah, but they never owned it because the masters were destroyed. I understand the law and I understand why it is the way it is.
Okay.
But if you look at law and common sense are often at odds. I mean, the truth is the masters were destroyed, but everybody knew that the masters were in possession of UMG or whatever.
Right.
They happened to get destroyed in a fire. And unfortunately, now they can't enforce ownership. But the reality is they do own them, or did. But that's not what the law will say.
yeah, that's it.
Yeah, that's right. That's right.
And
Anyway,
and
that's
it's not only that. I'm like hoping like one time there'll be a class action lawsuit against YouTube and stuff if they keep on like doing all this crap to those creators and stuff.
Yeah, well, I don't think YouTube should be a policeman at all. But,
no, I don't either.
Nobody should be a policeman for sure.
Yeah, no.
Because that's when if there is something that's similar to YouTube today, we'll be definitely be using that more for sure.
Perhaps. Anyway, so that's a 1/10 of an image, a 1/10 of a second exposure of the Jupiter system. It looks really, really good. You know, the data looks really, really good. I have no complaints there whatsoever. So here is the data from HW Virginis, the eclipsing binary star. So this is just a stack of all the images that my software deemed, you know, to be okay. So mostly what you're seeing here are stars. They're just really, really, really faint. Actually, this star right here is the HW Virginis. This dude right there, and I've got a couple other stars here that I can use to both be able to stack these images and also do photometric measurements. I can measure the magnitude difference between, you know, the target star and one of these. And then over time, I can look at the light curve and see if it changes. And of course, in this case, it not only should, but it does. And that light curve looks about like that. Let me zoom out a little bit here.
Yeah.
So this axis is time. It's just the UT time. And then this axis, which I know that you can't see all that well, is the magnitude difference. So what this is saying is that at this point, there was a magnitude difference of about 1.6 or so, and that actually dropped to almost 0.6, maybe 0.7. So in that case, what that means is that, come here, is that this guy got closer in brightness to this guy. So that means it dimmed. It dimmed down. So we're actually seeing a dimming event here, and that's exactly what was expected. So it looks really good. Looks like the other ones. I plotted this a different way too. I just, instead of points, I used lines, and that sort of smooths things around a little bit. So what I've got to find out what.
Patrick comes to himself.
Yes, Patrick, that counts. That definitely counts. You just need an interface, right? You just need an interface to, to plug in, and then you can record it. But we haven't figured that one out yet. So anyway, here's the light curve with connecting all the data points instead of just showing them. And it's noisy, but it's not too bad. It's not too bad. There's a variation here of, I don't know, maybe a quarter. Well, like what? Yeah, I mean, it's not all that bad. The only other interesting thing that I noticed was this part right in here, and I'm not quite sure what's going on there. If there's a gap in the data, I don't think so. You can actually look at the actual data points and see that no, there's no gap in the data there. So something, not quite sure exactly what what happened here, but I don't know if it might have just been an atmospheric thing. Who knows? It just things sort of change right in this area. But yeah, it's a nice curve. Looks just what I sort of expected to see. So looks good. This is all sort of preliminary. I really need to take this to the next step and get this into a model so I can actually play with some stellar parameters and see what kind of info pops out, that kind of stuff. So we'll see how all that goes. The only other interesting thing that I guess I want to point out is the following. And it's going to be a little bit hard to see here, but I'm going to try to do it anyway. Let's see if this might show it a little better. That might actually show it a little better. Okay, so if we go to the ephemeris, which is from the AAVSO, they have calculated for us what time this minimum should take place. Okay, and we can look that up in the ephemeris here. And for yesterday's event, here it is right here. I'll zoom that in a little bit. See that a little better.
Did Jim, maybe you should know, but did BMO like buy out Livestream? Because when I get my livestream.com notifications, and they always say something about BMO being there. And I was wondering if livestream.com brought out, not Livestream, BMO brought out livestream.com.
Don't know. Companies buy and sell things all the time like that, I think. So yeah, who knows? Anyway, so as you can see,
and there is some shenanigans.
Oh, are they any good? Let's see. Yes. Well, that's absolutely true. Well, and actually, it's a computer thing and a bandwidth thing. It's both. Anyway, so this was last night's event.
So just having a better computer wouldn't do it on its own?
No, that would
might help.
Yeah,
that would help half.
I mean, I got 100 megabits down and about maybe 75 up and stuff.
Wow.
So I'm good with the bandwidth. Okay.
You sure are.
But I probably could use a very good badass computer.
Yeah, I've got 10 down and 1 up here on a good day. So see, look, you've got the cloudy skies. I've got the slow internet.
And Uncle Bill's going to suck my
yours. All those satellites you hate may eventually provide you with better internet. But then what are you going to put on it? You won't be able to see anything.
Right. And look, just for the record, I don't hate them. I think that it's a problem that has to be dealt with because it's not going to go away.
Yeah, well, how are you going to deal with it? They're up there. They're up there.
Well, we're going to have to deal with it sort of post acquisition.
Well, you do.
Shenanigan.
What's going on over there? More shenanigans. Good. Yeah. Yep. See, Uncle Bill is watching the watch guy. He's watching a neurobiologist, Bill Nash. Yeah, I haven't actually gone on to Bill Nash's Twitch thing for several months.
I
So
might
yeah, I
even try
completely.
going there and follow him and stuff.
Yeah, he's just
Hey,
having a
you
good
missed
time.
check me out today.
Okay, yeah, I'm going to be out under the sky, so yeah, that's probably be a good opportunity to do that. Anyway, so according to the ephemeris, the middle of the eclipse is supposed to happen at 4:32 UTC. So that's approximately, I mean, really, really close to 4.5. 4.5. But if we look at this curve, what we see is that the minimum seems to happen around, well, it's definitely not 4.5. See, here is very, very clearly 4.5. Yeah. This is happening later. And this puzzled me for a little while. But let's go over to the AAVSO, and there's a very logical and kind of cool explanation for why there's a discrepancy there. It's just a couple of minutes. It's just a few minutes difference. But I want to show you the heading of the ephemeris for H.W. Ver, and what it says is ephemeris for H.W. Ver HJD. Now, HJD is what's called heliocentric Julian date. So what that means is that all these times, these dates and times, are as if you were standing on the sun. Okay? But since we're not standing on the sun, but rather on Earth, sometimes Earth is slightly behind the sun relative to the star, and sometimes it's in front of the sun relative to the star. So you have to account for light travel time. Because sometimes the timing is going to be early and sometimes it's going to be late. And so the fact that this, where'd it go? Where did it go? Whoop.
Oh my goodness.
Where'd my plot go? Oh, I don't know. Oh, here. The fact that this is a little bit late means that we're sort of on the other side of the sun from this star. I hope that makes sense. And so it takes the light, just a couple of minutes
Welcome
longer.
Andy Cowley.
Hey there, Andy. Nice to see you, Andy. Hope everything is well over there. So yeah, that really confused me for a little while, but then I noticed what the time thing is here, and this is according to the sun. There's actually a correction for that you can make, right? It depends on the geometry of the orbit of the Earth. Yeah, I mean, it's just a simple equation, but yeah, I thought that was pretty neat. That we're actually seeing a light time travel difference there. So I thought that was kind of neat. Anyway, so yeah, that worked out really, really well. There is another eclipse. This system does an eclipse about every 3 hours or so. So as you can see, today's eclipse is happening, at least the one that's sort of convenient, is happening right there. So that's 5:45 UTC, which for me, that puts it at I think 10:45 p.m. UTC. So that sort of defines my plan for tonight. Is that I will do Jupiter first, and I will do Jupiter till probably about 5 hours UTC, and then I'll switch over and I'll have a good amount of time to make sure that I can find the target. Last night, I gotta say, the telescope pointing was really good. Was really good, and the tracking was really good. So the telescope last night definitely gets the gold star. Here, I got it. Yeah, that's better.
Yeah. So somebody was asking Uncle Bill Druin about Jupiter's moon's current position. Ganymede and Io are both rather close to the eastern rim by now.
Yeah, in fact, I was looking at that also a little while ago. Oh, I guess I didn't keep it up here, but let's take a look at that really quick. I can pull up this little doodah here, and we can take a look at that.
Okay, so on this day in 1983, Sally Ride became the first American woman in space when she flew on Challenger mission for mission STS-7. Her second and final mission was also aboard the Challenger STS-41G in 1984.
Nice. Yeah, I heard about that Tom earlier today, and yeah, I remember that.
Wow.
I remember that one for sure. That was pretty nice and about time. Let's do. Is it the? Yeah, it's the 19th. Let's just look at. Well, let's look at 3 hours UTC. How about that? Let me make sure that I've got. Yeah. Okay. Field of view. Let's make it pretty big. Don't need any rings. Let me make these a little bit bigger. And here we go. All right, yeah, so there they are. That's as they're going to look in about, 22 minutes or so. So EO, I don't know if EO is going in or out. I'm not quite sure.
And make sure that you check the Discord. I think Uncle B posted like a screenshot of the current locations via Stellarium.
Oh, good. Yeah, it might be interesting to compare these two. Let's see. Where do I need to go here? I need to go over here. Let's go over to the Discord. Go up here. So, okay, so he posted this. This is... Okay, so this is local time. So for me, that's what, 2:37. 2:37. So let's see. We can go back here and I can punch that in. It's always kind of interesting to have the opportunity to compare these to see if there are any obvious differences. I think I would hope that they'd be using the same models. So there's what this program shows, and that's what Stellarium shows. And
I don't see EO or something.
Yeah, all four of them are there, right? Here's Here's Io and Ganymede, or these two guys. Callisto's out here still, and Europa's over here. So
Okay.
I think that's about right. That looks really, really close. I mean, these two are sort of near each other. Yeah. And Europa's way out here on the other side, sort of north, right? I mean, if I were to draw a straight line, it'd sort of go this way. So it's a little bit north of that straight line. And yeah, I think so. So yeah, those look pretty close. We can, where does it say the RA and DEC here? That's another interesting thing to look at. So 1708-37. Let's see where this thing says it is. Where am I? 1708-37. Pretty good. And negative 2220-45. Negative 2220. Oh, 43. I thought I already had. So there's a little bit of a discrepancy here. Maybe it has to do with the exact second here.
Chuck Diagram has a friend in the Navy that used thorium to guide their submarine. They did it for music purposes. It was said it was pretty accurate.
Yeah, well, that's saying a lot. Yeah, that's definitely saying a lot. So yeah, even if I put it.
Have you ever had a chance to capture the Saturn, Uranian, and Neptunian moons?
I have looked at Saturn's moons. I can see I don't know, 4 or 5 or 6 of them. Yeah, I'm kind of interested in maybe doing exactly the same thing with Saturn as I'm sort of moving towards doing with Jupiter, and that is just measuring the positions of these guys as they move, and also their brightnesses as they move. So all right, so yeah, it's off by a little bit. 45.2 it says here, and this says 43.5. So it's off by almost a couple seconds of arc, which isn't too bad, but there is a discrepancy there. It's kind of interesting that there is. So, but yeah, that's sort of the situation.
We also did a screenshot of where they're currently now.
Okay, cool.
We're off to close that out and look at it.
Let's see. Posted another one. I don't see it here.
Okay.
I don't see it.
Yeah, I don't see either.
Oh, okay. I thought you said he posted another one.
I thought he did.
Ninja Uncle Bill doing the mind trick over the internet. It's pretty amazing. Anyway, yeah, so that's how it's going to look here. Like I said, I'm not quite sure. I think Io is going out. Europa looks like it's pretty close to about as far out as it's going to get. Maybe it gets a little bit further. I'm not quite sure. Ganymede and Callisto for sure are coming in. They're moving west. So yeah, that's sort of the situation with Jupiter and HW Ver. I guess I'm just going to be doing almost exactly the same thing today. It just yeah, it's part of the part of the grind. Oh yeah, let me show you this too. I've got those stacked images here in DS9, and I was just with this. We can sort of play around a little bit with the various button things and all that, and really take a close look. So the tracking was pretty good. There's also field rotation that I have to take into account. So that's why they're all sort of turned around a little bit, because
thank you for the clarification, Uncle Bill. And Astro Live Channel said he saw some astrophotographers that captured Neptunian moons with Triton. I didn't try to catch them in the future. I only captured Jupiter and Saturn moons.
What kind of scopes do they have? That Neptune's moons? Wow.
Well, I mean, Neptune's moon Triton is pretty. I mean, it's far away, but it's pretty easy to see. Uranus's moons.
But the way he worded it said that his astrophotographers captured Neptunian moons with Triton.
Right. Yeah. So yeah, I mean, it's not as difficult as you might think, and actually, Uranus's moons, because of its weird inclination, are actually pretty easy to see. So yeah, I mean, even with the telescope, just looking at it, as I recall, I think you can see Triton with a reasonably sized scope. You probably need, I don't know, at least an 8, if not more. And
like
Uranus's
8-inch?
Yeah. And Uranus's moons too. As I recall, somebody correct me on that if I'm wrong, but I recall seeing those. Anyway, so yeah, this looks really, really good. The stacking is nice. The seeing was pretty good. I mean, ideally, these should all fall on 1 or 2 pixels. So there's a little bit of a spread there. So the seeing wasn't great, but it wasn't all that bad. And probably my stacking isn't perfect either. So there's a little bit of a blur there, but overall, yeah, looks good. And all these faint guys in here, these are all stars. Yeah, faint ones. These are I think these are around like 17th magnitude or so, 16th or 17th. So they're really, really, really faint. HW Ver goes from about 10.5 to 11.4 or so, and I think this guy, one of these two, the brighter of the two, I think that's this one. I think is around magnitude. I think. Oh, I don't remember now. I want to say like around magnitude 12. So that's not bad. It's not bad. That's 400 images stacked. I'm still seeing a little bit of a while I do the analysis of this, I'm still seeing a little bit of a slope here. You see how it's sort of brighter over here than it is over here. So I'm not quite sure if that's the flat field, if it's the data itself. I'm just not quite sure. It's really subtle, but it is definitely there. So yeah, that's kind of a mystery. I don't think it's really affecting any of the measurements or anything because it's really, really low level, but pretty nice. This this tool has various color tables that you can sort of play with, and
Most illogical.
Well, I don't think so.
Over my dead body spot.
Yeah, really. How rude. But changing the color tables often allows you to see subtle things that you may not see with just a grayscale. So things just pop out a little bit more sometimes. But so you can definitely tell that there's a slope here. See how it's bright over here, or well, purple over here and green over here. So there's some differences, really low level. So here's another palette. Pretty good. Here's another one. Kind of cool.
And these are like the Jupiter moons, right? Or just Jupiter?
No, this is HW Virginis. This
okay.
star right there is the eclipsing binary star. But I can also do a stack just to sort of see what we see. So pretty interesting. Let's see what this one looks like. There's this one. Of course, I've still got these little tails here. So you see this here. That I'm absolutely 100% convinced that is as the camera shutter is moving across the star, the light is diffracted just for a moment, and so it's making this weird tail. So this is caused by the shutter, and again, it's really low level. So at this point, I'm not too worried about it. Not worried about it yet. Here's this one. That one's called Cool. And then there's a rainbow one, I guess. Let's see what that looks like. It's like all the other ones. I really like this little binary here, right in the middle. It's become a fast friend.
Look at
Can't see it in the raw data. Here, let me show you the. I'll show you the first image of the calibrated data. So that's here. I'll put it back to gray so you can see. So that's what one image looks like, and that's a 3-second exposure. Oh. So that's what it looks like there. Let's see. Do I have? Oh, let's make a new frame, and let's open up, and let's put this guy here. That. So there's the stack, and there's this one. Oh, let's back this out a little bit. Let's see. Is that gonna be right? Oh, not quite. Here we go. Nope, that's not quite right either. Oh, maybe I need to do that one more time. There we go. There we go. So now let's, I'm going to try to stretch this thing a little bit. See if we can really just get the best possible stretch here. A little bit of noise. Let's go over to the next one. Do the same kind of thing. You can really see here when I blink these how that really increases what's called signal to noise. So, you know, this little binary star here isn't even visible in the individual image. But if you stack 400 of them, you got them. Kind of neat. All right, well, cool. I think I'm looking at the clock, and I'm looking outside. It's starting to get darker. So I think I'm gonna head on out. Let's see, stop sharing. Cut this off just a tiny bit early because Mr. Scope and I have got. I think I've got to get out and collect some more photons. So I'm going to check the chat one more time, real quick. Looks like there's been great discussion. I like it.
Yeah.
Oh, the software that I am using to stack is my own. I'll have to. I think I've talked about how I'm doing it, and I can definitely do that again. Somebody just needs to remind me. I'm not going to do it now because it's a little bit involved. It's not huge, but yeah. It's just my own. I'm not really a control freak, but I got into programming early, and I know how powerful software can be. So I'd like to have that power right here, and not having to hope that something is going to work right, or on the phone being like, well, can you add this feature? No, I'm just going to do it all myself. So I'm lucky that way, or blessed, as I said. So, okay, everybody, I'm going to get out of here for now. Jupiter, ho, and HW Ver, ho. It is clear, beautiful, and I wish I could share it with everyone. But the next best thing is for me to just go out and do it. Right?
Yeah.
So
I hate you. Go ahead. Good luck. Really?
Look, I'm not even sorry, right?
I know you're not.
I'm not even sorry. So I'm sad that you've got clouds.
I bet it's.
I'm not sorry. So, all right, everybody. I'm gonna get out of here.
Good night.
Peace, cheers, and all that. Live long and prosper, and I will see you on the spin. One rotation of this tiny little spheroid we're on. Okay, everybody, take care. I will see you later.